So hello everyone and welcome to this new course on earthquake resistant design and detailing of steel buildings that we are going to start from today. And this is our session number 1. So I hope my voice is audible to all of you because all of you are on mute and you cannot turn on your videos as well. So the only way to communicate during the sessions would be to type in the chat. So for live audience who are going to watch these sessions live, if you want to communicate or if you want to ask any doubts, difficulties, questions, the way to do it is by writing in the chat box. And we regularly monitor the chat box. So whatever you write, we will monitor and we will respond to it. So yes, I am audible, and I would like to thank all of you. Me and Akanksha thank all of you who have joined this course. Uh, and I think it's going to be an interesting course that we will have on an important topic for those who are involved in doing steel designs of steel structures. If you are a practicing engineer or a working professional or a consultant doing steel designs, then I think this would be an important course for you. It is important for us also because in the duration of this course, we will also learn a lot of new things uh, together with the participants. So let us begin then with this session 1. So I'll just briefly tell about the agenda of today's session. And today I think would be the only time we will be taking a session on PPT. Otherwise, it will all be written work or we will write down things on the whiteboard. So generally first session we take on presentation so that we can just highlight the a few important points that we would be taking in the course. So therefore, we usually take the first session on PPT. So what we are going to discuss today. So I'll just tell you about the codal scenario and the overall state of affairs right now when it comes to this issue about the earthquake resistant design and detailing for steel buildings. So what is the perspective or what is the codal scenario in other countries and what is happening in India, the historical development that I would like to begin with by throwing some light on that issue. So that will be the first point that I will be taking up in today's session. Then we will go to why did we think that such a course should be conducted? What is the need for this course? So this is the second topic that I would be taking it up. Need. Then we will go to after the need, the course contents. I had told about the course contents in the introductory session as well, but I'll just briefly touch upon it once again. I hope all of you are able to see this PPT. Those who are joining us live, are they able to see this presentation? Yes. And you are able to listen to my voice and see my video as well. Okay. Yeah. So the course contents, even though we have discussed this in the introductory session, we will just quickly go through it once again. Then after this, we will go to the approach that we will be adopting in this course, how we are going to progress in this course. That would be taken up next, the approach. After the approach, sorry, this course content should not have come twice. I think from here I need to cut. First, I'll be taking up the approach and then I will be taking up the course contents. And then we will, I think this philosophy thing, I'll just briefly touch upon today and maybe discuss it in greater details tomorrow. Okay. What is the philosophy or what is the thought behind the subject of earthquake resistant design and detailing? So these are the topics, these are the points that we are going to cover in today's session. So let us begin with the scenario, the codal scenario, what is happening in India and what has happened in India in the past, what has happened in the uh, other countries when it comes to earthquake resistant design and detailing for steel buildings. So before that, I would just like to ask a few questions over here that what is the code for earthquake resistant design and detailing of steel structures in India? Yes. What is the code? What is the code for earthquake resistant design and detailing of steel buildings in India? So it is the newly launched IS 18168 that was recently launched as recently as last month. So this is the code that we have. So the question comes then what was happening before the launch of this code? That is the question we would like to answer first, that what was happening before the launch of this code. And even before I go to this, I would just like to ask you that what is the code for calculation of earthquake forces, or what is the code that deals with the earthquake load calculation in India? So which is the code that deals with the overall EQ calculation? So I think all of you know, as Ajanji is saying, that it is the, and Mr. Umar Farooq is saying that it is the IS 1893. So I'll just like to give a brief historical overview of this IS 1893. So does anyone know when this was launched first? IS 1893. When was it launched first? So it was launched first by a joint effort of University of Roorkee professor, University of Roorkee Civil Department. Mr. Umar Farooq is saying that this code was launched first time after. No, no, no. So uh, I think sometime in 1957, when Professor Jay Krishna, I think you might have heard his name. So Professor Jay Krishna joined this University of Roorkee Civil Department, and there started a lot of work on the overall development of some standard for earthquake load calculation. So I think in 1957 the work started, and the first IS 1893 was released in which year? So first IS 1893 was released in 1962. Okay, as long as this is what I think 60 years, 62 years before this code was launched. And Roorkee did a lot of work, University of Roorkee, which is now IIT Roorkee. And this is where from I and my wife, we both have done our masters from here, IIT Roorkee. So they were the pioneering institute in development of the earthquake codes and earthquake standards. And even to this date, there is a lot of work that happens at IIT Roorkee when it comes to the the overall subject of earthquake. There is a lot of work that happens at IITR. So the first time this code was released was in the year 1962. Subsequently, it got revised in the year 1960, I think 7. Then it got revised in 1970. Then it got revised in 1975. Then it was revised in 1984. I think after 84, someone may be able to tell the next edition. After 1984, it was revised in which year? After 1984, it was revised in, yes, 2002. And as Mr. Umar Farooq is saying that in 2002, there were some major revisions. There was a overall redevelopment or rethought given to the philosophy of earthquake loads and earthquake calculations. So in the year 2002, it was also divided into 5 parts. Okay, so it was the first time that IS 1893 got divided into 5 parts in the year 2002. So you have got part 1, part 2, part 3, part 4, and part 5. I think part 1 is for general calculations and buildings, part 1. Part 2 is for what? Part 4 is for industrial structures. Part 2 is for liquid retaining. Yeah. Part 2 is for liquid retaining structures. Part 3 is for I think one part is for dams. I'll just open and see which parts is for which. Let me just open and show it to you. I think I'll show you the old 1893 2002. So part 3 is for bridges. Mr. Omar Farooq is saying part 3 is for bridges and retaining walls. Very good. Just give me a minute. I'll just open the old 1893 part 2. Sorry, I'll just open the old 1893 2002. Can you see this? This is the old 1893 2002. So you can see Pachwa Punarikshan, Pachwa fifth revision. So why fifth revision? Because from 1967, 1970, 75, 84. So this is the fifth revision. And if you see over here, it was the first time that the code was divided into 5 parts. So you can see over here in the fifth revision, with a view to keep abreast with the rapid development and extensive research that has been carried out, 1893 has been split into the following 5 parts. So general provisions and buildings, liquid retaining structures, bridges and walls, bridges and retaining walls, that is, industrial structures, and dams and embankments. Okay. So these 5 parts were developed, or rather the code was split into these 5 parts. And now you may be aware that in the year 2022, there is a 6th part also that has been published. How many of you have seen the 6th part of 1893? Hello. Anyone who has seen the 6th part, part 6? So part 6, if you are not aware, now there is a part. Let me just finish this. Part 3 is what? Part 3 was bridges and retaining walls. Part 5 was industrial structures. Part 4 was industrial structures, and part 5 was dams and embankments. So these were the 5 parts that were published in the year 2002. Anyone who is aware about a 6th part that was published in 2022? So in 2022, a 6th part was published, and that 6th part is for, yes, as Mr. Omar Farooq is saying, base isolated buildings. So for base isolated buildings, this 6th part was published. So overall, this was the scenario in the year 2002. Rajanji is asking, so even part 4 was not covering steel structure up to some extent. See, it was covering all sorts of industrial structures, but this part 4, if you read, it talks more about the overall load calculations. It talks more about the response reduction factor to take, but it does not tell about the design principles and detailing principles. So here we are in this course that we are going to conduct. We want to know more about the design and detailing principles. Earthquake load calculation, I believe all of us understand. So that is not the thing that I'm going to focus on in this course. Here we are going to deal more with the design and detailing aspects for seismic loads. So that was not covered in part 4. 1893 part 4 only talked about the load calculation for industrial structures. I think some of you might have gone through this code. In our previous courses, we have dealt with this 1893 part 4. extensively. Okay. And this was also revised in the year 2015. And then there has been a draft that is in circulation right now. And I think that draft will also get published soon. Or has it already published? No. I think part 4 draft is under review right now. And that will be soon published. That is my understanding. In 2022, a draft was released. And I think it will also get published quite soon. Okay, anyway. So 2002, this thing happened. And why did 2002 happen? Why there was a wholesale changes made in the 1893 in 2002? Anyone? Why do you think such uh, significant changes were made in this year 2002? Anyone would like to guess? So wholesale changes or large changes were made in 2002 because of what do you think was the reason? Hello. What do you think was the reason? Yeah, so 2001 Bhuj earthquake was a major reason. Correct. 2001 Bhuj earthquake, which struck on 26th of January 26th of January 2001. This was a major reason to lead to which led to having significant changes in this 2002 code. Then after 2002, it was revised in which year? 1893. After 2002, it was revised in 2016. And after 2016, now we may expect, I think most of you must have read 1893, I think part 1 and part 2 draft. Have you read for the year 2023? I think 2023. Yeah. There's a draft in circulation for 1893 part 1, part 2. Have you read that? And again, these parts are going to be reorganized now. So sort of part 1 has been split into two parts, you could say. So this part 2 is now for buildings and part 1 is for general provisions. So this is still a draft. This is still at the draft stage, but I think you might have gone through them. Anyone who has gone through them or at least heard about it, that such a draft is under circulation right now? Anyone? No? Okay. So if you have not gone through it, you can easily download it from the BIS website. I hope you all know that the BIS codes are freely downloadable from the website. Are you aware about that? You can freely download the IS codes from website of Bureau of Indian Standards. So I think their website is bis.org. Earlier you had to purchase them, but since last 4 5 years, yeah, of course you need to sign in. Of course you need to create login. You need to create an account over there by giving your email, password, etc. But once you sign in, you can freely download it, the PDF. If you want to order a hard copy, you have to pay some money. But if you just want to download a PDF, you can freely download it. Okay. So you just go to bis.org website, sign in over there, and download any code that you want to download. So now 1893 part 1, part 2, they are also going to be reorganized. So now part 1 will be more of a general provisions. Part 2 will be for buildings alone. And then it will lead to changes in the subsequent parts as well. So this is going to happen maybe in 2024. We may get a new revised 1893. So this is the scenario that we have for 1893. So 1893 only deals with what? The IS 1893 only deals with the earthquake load calculation. It only deals with the earthquake load calculation and analysis. That how you will analyze your structure for the first of all, how will you calculate the earthquake loads? Then once the earthquake loads are calculated, how you will analyze the structure. Okay, what are the methods that you are going to use? When to use the equivalent static? When to use the response spectrum? All these things are covered in IS 1893. So for load calculation, you have got the load calculation, analysis, and I would say the lateral load resisting system selection. Which lateral load resisting system to select, and the checks that need to be adopted. All these things are covered when I talk about the Indian perspective in 1893. Now, once you calculate the load, once the loads are applied, once you analyze the structure as per the requirements, after analysis, what is the next thing that you have to do? Once your structure is analyzed, once you have found out the member forces, moments, shears, whatever, then what is the next thing that you have to do? Hello? Are after analysis, what's the next thing that you do? So next thing you need to do is the design and detailing. Yes or no? The next thing that you need to do is the design and detailing. So sorry, for design and detailing, what do we have? Just give me a minute. Yes. So for design and detailing, once the analysis is done in the Indian perspective, what do we have for design and detailing? So I'll just like to throw throw light on the codal scenario about the design and detailing. Okay. So let us see, once this IS 1893 was launched in the year 1962, which dealt mainly with the earthquake load calculations. Then in the year 1967, in the year 1967, for the first time, a code was launched, which was IS 4326. Actually, I've written down these few things on a piece of paper. So this IS 4326 was launched in the year 1967. Once this 1893 was launched in 62, after 5 years, this was launched, and this dealt with the EQ, earthquake resistant design and detailing, design and construction. It dealt with earthquake resistant design and construction of buildings. Okay. So this was more of a general prescriptive code that you should do this, you should not do this, do's and don'ts type. Okay. It was less on mathematical calculations. It was more on prescriptive basis that you do this, you don't do this, do's, don'ts. right, wrong, that type of a thing. Okay. So this was again mainly dealing with the concrete construction. This was mainly dealing with the concrete construction. This came in 1967 and it was subsequently revised in the year 1976. So after a gap of what, 9 years, this got revised. Then in the year 1993, there were four codes that were made in this year dealing with the design and detailing aspects. So I'll just highlight those four codes. One was the IS 13827. This dealt with improving EQ resistance, EQ resistance of earthen buildings. Okay, very interesting. Earthen buildings. Do you understand what are earthen buildings? Anyone who does not understand what is an earthen building means if you go to any rural part in India, you will see small houses made of earth, मिट्टी के घर. All right. So if you go to these rural areas, then you will nowadays even you in the rural areas, it's hard to find an earthen house made. But this is 1993, so we had in those days, even in the rural areas, we had earthen buildings being made. So we had this code improving EQ resistance of earthen buildings, IS 13827. Again, it was less on mathematical calculations and more on prescription. Then you had the IS 13828. So this IS 13828 dealt with improving EQ resistance of low strength masonry. So for example, if you have a low strength masonry of M5 grade or even lower, then structures made out of those, again in a lot of rural areas, even in small towns, you will get a lot of structures made out of masonry. So improving EQ resistance of low strength masonry. Then you had the IS 13935. This talked about the repair and seismic strengthening of buildings. Okay. This talked about the repairs and seismic strengthening of buildings. And then the familiar code that I think most of you are familiar with, IS 13920. I think all of you have heard this name, IS 13920. So what was this code? This code was ductile detailing of RC structures. Hello, am I audible to everyone? So this happened in 1993. So if you notice, India was perhaps the only country in the world which had a code on non-engineered buildings and which also had a code on low-strength masonry buildings and which had a code on RCC structures. So it had multiple codes for different types of structures and how to improve their earthquake resistance. So India at that time was perhaps the only country which had all these different options of codes for different kind of structures. But you will notice one thing is still missing over here. And what is that? What is that one thing that is missing in all these four standards that I've listed down? There is one thing that is still missing. What is that? So the RCC structures are covered, the masonry is covered, the earthen buildings are covered, but steel structures are still missing, isn't it? Hello? Yes, no? Steel structures is still missing. That means there is no code for ductile detailing or design for earthquake resistance for steel structures. So this is all RCC right now, or earthen buildings or masonry. Then in the year, which year this 13920 again got revised? Which year this 13920 got revised? So 13920 got revised again in 2016. And there were again wholesome changes made into this code. And now even the name got changed. So the name now became Ductile Design and Detailing. What was the earlier name? What was the earlier name? So earlier name was only Ductile. The earlier name was only Ductile Detailing. It only had some detailing principles. You put your bar over here. You don't put a reinforcement over there. You put more stirrups over here. Those kinds of detailing principles were given in the 13920 1993. But in this year 2016, there were wholesome changes made and design and detailing principles were also adopted. Do you understand? Hello. But you will again notice that this is only for RCC structures. This is only for RCC structures. So what is still missing in the puzzle? What is still missing? Hello. What is still missing? Steel is missing. Yeah, steel is still missing. You still don't have a code which talks about the earthquake resistant principle, design and detailing principles for steel structures. So I'll just write down that for RCC structures, you had a code as old as IS 4326, which got released in the year 1967 and which was subsequently revised till 2016. It has been revised, but the the piece of puzzle that is still missing is you don't have a code for steel earthquake resistant design and detailing. All right. I think so far so good. Hello. Yes, no. Okay. So I think we have at least understood the Indian scenario right now. Now, before moving ahead with what happened in steel, when was the first time there were some provisions given for steel uh, ERDD? When I say ERDD, earthquake resistant design and detailing. Okay. So when was the first time that in a code a few principles were added for the ERDD of steel? Someone had just mentioned a few minutes ago. So for the first time, when some principles for ERDD of steel structures were adopted, was I think in IS 800 2007 in the form of one section called as Section 12. Okay, so that was the first time a few concepts about it were introduced. But before I go to Section 12 of IS 800, I'll just take you to the scenario in the US in the American context, that what was the scenario over there. All right. So just like we have IS 1893 for earthquake load calculations, in the American context, what is the code which tells you about the load calculations, earthquake load? Actually, it talks about all the load calculations. So which is the code which talks about the load calculations in American context? Which is the American code which talks about the load calculation? Anyone? So it is the ASCE 7. Okay. So they have this code ASCE 7, which just like the Indian code, it talks about the load calculations for structures. But then this talks about all the load calculations. For example, in the Indian context, we have a different code for dead load. We have a different code for live load. Okay. We have a different code for wind load. I mean, the parts are different. But here there is one code, ASC7, that talks about all the load calculations. And just like we have IS 800 for the design of steel structures, what is the code for American? What is the code in the American context? So that is the, yes, anyone? Which code is similar to IS 800 when it comes to design and detailing of steel structures? So that code is, if you are not aware, that code is AISC 360. Okay, right. So why I have jumped to American scenario right now straight away? Because once we understand what was happening in America, then we will be able to understand what happened in India subsequently. Okay. So therefore, first, I would just like to inform a few things about the changes taking place in the American steel research. So in America, they had this AISC 360, which covered a lot of things, and it mostly covered the seismic and the non-seismic both. It used to cover in one single code, the seismic, non-seismic, everything it used to cover. Okay. Then in the year 1994, those who have done masters may have heard about this. In the year 1994, there was this large earthquake that was called as the Northridge earthquake. Have you heard about it? Yes, tell me. Anyone who has heard about Northridge earthquake? Those who have done their masters and those who have worked on time history, usually we use time histories of these past earthquakes. So I think Northridge is one earthquake whose time history is used for analysis. So in the year 1994, after the Northridge earthquake, there was a lot of churn that happened in the steel industry, and that was a lot of rethinking. There was a lot of thought that was given to the scenario of steel structures and structures overall, because a lot of steel structures did not perform as per the expectation. So after this, this is near Los Angeles, by the way, near LA, California. So California, if you know, is one of the most seismically active region in the world, and which is the fault line. So the fault is named as the San Andreas Fault. Have you heard about it? So this San Andreas Fault actually runs the entire length of this American continent, right from US parts of uh, northwestern United States, right up to South America. Okay. So this San Andreas Fault is a major fault line that you have, which runs along the western edge of the American continent. Okay. So after this Northridge earthquake, there was a lot of rethinking that was given, and a lot of codes, especially related to earthquake, got revised. This EQ, just like in India, which earthquake had an impact on a lot of changes in the earthquake codes. So in India, we had this 2001 Bhuj earthquake, which led to a lot of changes being made in the code. Similarly, in the American context, after the 1994 earthquake, there were a lot of changes that were made to their standards and codes. Okay. So you can say that earthquake teach a lot to EQ teaches us. Okay. Every earthquake event that takes place, it teaches a lot of things to us, isn't it? Because see, this entire thing about earthquake engineering, it is based on a lot of research and a lot of theoretical assumptions, because you don't get to see earthquake every day, isn't it? So it's more it's based more on the laboratory work that is happening, the test models that are being developed and tested. So real time earthquake may come, big earthquakes may come once in 20 years, 50 years, 60 years at a place. So only when there is an actual earthquake that takes place, it teaches us few things, mainly the engineering community, isn't it? So just like in 2001 Bhuj earthquake, it taught us. The 1994 Northridge earthquake led to a lot of changes being made, especially to steel structures, because they observed that the steel structures, especially the moment resisting frame systems, did not perform as per expectation. Okay, do you understand? Hello, am I audible to everyone? Yeah. So then a lot of changes were made, and subsequently the AISC seismic provisions after the 1994 Northridge, the AISC seismic provisions were rewritten in the year 1997. Okay, lot of work also happened under FEMA. Lot of work also happened under FEMA. What is FEMA? So FEMA is federal. Federal means in the US there is one thing that is the state, and then the other thing is the federal. Okay, so Federal Emergency FE Management Authority Agency. This is the FEMA. Just like in India, you have what? In India, you have a similar organization that uh, deals with the emergencies or calamities that you may experience in parts of India. What is that agency called as? Arre, you might have heard about it. No one? NDMA. Yeah, NDMA. Okay. Mr. Kashyap is saying NDRF. That is more of a force. NDRF is more of the force. That means it consists of the people who will be deployed in case of emergency. Okay, so they will go to the site wherever, let's say, an earthquake has struck, or there is some cyclone, or there is some high wind event or landslide. So NDRF is the force. It will go on the site for evacuation and for helping out people. But the agency that is behind it is NDMA. So it is the national, just like FEMA, it is the uh, National Disaster Management Authority, isn't it? Disaster Management Authority. And just on a side note, if you see after the Gujarat earthquake, a lot of work that was put into the revising the earthquake codes was done by the GSDMA, Gujarat State Disaster Management Authority, in association largely with IIT Kanpur and also NIC Triple E. So the NIC double E or Triple E? I think Triple E, NIC Triple E. So these people did lot of work on the revising the codes, and their work mainly led to the revision of IS 1893 and 13920. Okay, so this was just a side note. NIC double E, yeah, not triple E, double E. National Informatics Center for Earthquake Engineering. I think that is the full form. Is that the full form? National Informatics Center for Earthquake Engineering. Yeah. So this is what we have in India, NDMA, similar to FEMA. So coming back, I was just telling you that after the 94 earthquake, the AISC seismic provisions were rewritten in 1997. Then your FEMA also came out with uh, codes mainly dealing with steel structures, FEMA 350 to 355. So all these series of codes that FEMA came up with, it talked more about the steel structures. Why am I focusing on steel structures? Because that is the topic of our course. And why a lot of work was done in steel structures? Because the 1994 earthquake showed that the steel structures did not behave as per expectation. So there was a lot of work that was carried out. Okay. Then there is another agency which is called as the NEHRP. Again, all these are American agencies. So anyone who knows about NEHRP, they come up with some excellent documents for practicing engineers about the seismic design and detailing and load calculations. I'll share a few of them with all of you. They are easily and freely downloadable from the internet. I'll recommend you should go through those documents because they are made with an intention of helping the practicing engineers mainly. So NEHRP is what? NEHRP is the national means American national. So National Earthquake Hazard Reduction Program. Okay. NEHRP. Of course, they deal with all types of structures, whether it is RCC or steel, but their documents are worth reading. And again, I will request all of you that you must go through these documents. They are made with an intention of helping the practicing engineers and working professionals. So NEHRP also did a lot of work. So AISC did a lot of work. FEMA did a lot of work. What is the full form of AISC? American Institute of Steel Constructors. No. What is the full form of AISC? American. Let me just search for the AISC full form. Yeah, American Institute of Steel Construction. AISC stands for American Institute of Steel Construction. So all the steel related codes, all the steel related codes in America are published by American Institute of Steel Construction, AISC. And all the other concrete related codes are published by what? Yes, tell me. All the concrete related codes in America are published by ACI. Yeah, American Concrete Institute. So any standard that is related to concrete is published by ACI, and any standard or code which is related to steel is published by the AISC. So just like we have IS 456, which is the American code for concrete structure design, it is the ACI 318. Just like we have 456 over here, over there they have this ACI 318 for concrete structure design. Yeah. So AISC, FEMA, NEHRP, they did a lot of work for, especially for steel structures, particularly after the 94 earthquake, and they came up with a lot of documents. So AISC revised its standards 360, and it also introduced a new standard, especially for seismic provisions of steel structures. So they made a separate code, seismic provisions of steel structures, and they named it as AISC 341. So 360 deals with the general provisions for steel structures or general specifications for design of steel structures, and 341 specially deals with the seismic provisions. Do you understand? Hello. and these were revised. So usually what they do is, which is a good thing, this 360 and 341, they revise it together. Okay. So if they are revising 360, they will also revise the 341. So I don't remember all the past years, but as far as I can remember, it was revised in 05, then it got revised in 10. After 10, I think it got revised in 16, and after 16, now you also recently have, just last year, a 22 revision was also launched. Okay, AISC 360 2022 or 22. So all these revisions have been made to AISC. 360 deals with the general steel structures, just like IS 800, and 341 deals with the seismic provisions for steel structures. Is it clear? Hello. So after a lot of work was done in the late 90s to early 2000s, in the late 90s to early 2000s, after a lot of work was done in America, especially for steel structures, we also took a cue from there. We also took signal from there, and then when we revised our IS 800, so now I'm coming back to the Indian scenario. Till then, we did not have any steel, any code that talked about the steel ERDD. But after a lot of work was done in America in that decade between 1995 to 2005, when we revised our IS 800 2007, sorry, when we revised our IS 800 in 2007 year, we also included a section 12. I'm coming back to the Indian context right now. So section 12 was introduced in IS 800 2007. Is it clear? Hello. Quick yes, no, please. Is it making any sense to all of you? Do you understand why are we discussing all these things? So we are just discussing all these things to get a perspective of what is happening and what is the historical context of these things. Okay. So 800 2007 for the first time gave these recommendations for the steel structures, seismic steel structures subjected to seismic loads. I'll just take you to IS 800 2007. 2007 was a major revision because before that you had the IS 800 1984, which was based on the working stress based method, and then uh, when it got revised in 2007, it was a major revision. So I just want to show you, they have actually not mentioned over here. Generally in the code forward, you must always read the forward of any code that you are reading. It gives you an idea of the background behind the development of the code. So here they have not written it, but the section 12, which dealt with the seismic design principles for steel structures, was added for the first time. So this is the section 12. Can you see this PDF? Hello. Design and detailing for earthquake loads. Clear? Yeah. So this happened in section 12, and this took the recommendations again mainly from the AISC 341. So generally Indian codes are a cut copy paste operation that they do on 341 or any American code. Okay. I don't know what the committee works because they just directly pick from there. There is no thought given that what will happen in the Indian scenario. They just pick it. Anyway, so we got this section 12. Is the development Clear till now? Hello. Is the chronology of events clear till now, that what was happening in the Indian context, what was happening in the American context? So, if I would like to summarize, we have got 1893 for earthquake load calculations. 1893 has several parts, and the parts were developed in 2002 for the first time, and subsequently a sixth part was added in 2022. And these parts get revision from time to time. So 1893 is for load calculation. Then we have, or rather we had, design and detailing codes for masonry structure, not design and detailing, but we had prescriptive codes for the earthen buildings. We had prescriptive codes for masonry structures. We had prescriptive codes for repairing and seismic strengthening. We also had a ductile detailing of RCC structure code, but we never had any code for design and detailing or earthquake resistant design and detailing for steel structures until IS 800 2007 section 12, which included few points about the ERDD of steel structures. So that is still 800 2007. Okay. This was the scenario. And in the American context, after 1994, after their Northridge earthquake, Western US mainly did lot of work in. So where, if you see, just on a side note, where do you see most of the work happening for earthquakes, or where do you see most of the work happening for dynamic effects in structures in America? Where do you see it happening? So you will see most of the work happening in the Californian state. Okay. You will see most of the work in USA when it comes to earthquake happens in the state of California. So you have this university, Berkeley, as Mr. Kashyap is saying, University of California at Berkeley. Most of the work on dynamics, if you have read about A.K. Chopra, have you read his book, A.K. Chopra, Professor A.K. Chopra? So he is a professor, or rather, I think, I don't know how old is he, or he's still there. I'm not aware. But Professor A.K. Chopra is an authority in dynamics of structures, and he again comes from UC Berkeley. Or if you have heard about Clough Penzine, Ray Clough and Penzine, Clough Penzine, have you? I may not be sure about their names, but if you read their book, it is also a very, yeah, it's a high level book. Even A.K. Chopra is quite an high level book. And if you read this Clough, Clough, I may not, Clough Penzine, yeah, Dynamics. This is again a book. Just give me a minute. Yes. Is my voice audible? Hello. Yeah, Clough and Penzine, Joseph Penzine and Ray Clough. So their book is also one of the one of no, one of the very well recognized books in the dynamics of structures. So they again are from UC Berkeley. Then you have got this fellow who developed the finite element method. What was his name? Who developed the finite element method? Uh, Anyone who knows? I am forgetting his name. Ben, I mean, the numerical concepts of FEM, not the FEM per se, but the numerical approach to FEM. What was his name? I'm forgetting. Ben, anyone who knows his name? He had published a very good paper. No, no. I'll just reiterate. I'll just rephrase it. Not the FEM development, but the numerical approach to finite element method. Okay. Uh, that how you can numerically do the FEM based analysis in computer or using the computing techniques. Who was that guy? Ben Crocker? No, I'm forgetting his name. Uh, Mr. Umar Farooq is saying, oh, Zinkiewicz is the pioneer of FEM. Yeah, yeah, but I just want to know numerical method, that how it can be done on computers. Who was that guy? I'll tell you in the next session maybe. But why am I telling you? Because this fellow who did a lot of work on the numerical method development using the FEM, they his work mainly led to the creation of CSI. His work, I'm forgetting his name by the way, but his work in the field of numerical calculations and developing numerical methods for finite element analysis led to creation of CSI. What is CSI? What is CSI? So CSI is Computers and Structures Incorporate. Computers and Structures Incorporate. And why is it of interest to us? Because this CSI develops the products that all of us use, that is the ETABS or SAP 2000 or SAFE. So all these products are developed by the CSI company, Computers and Structures Incorporate, which was actually incorporated at UC Berkeley. Okay, so the students and the professors of this institute came together to create this company CSI, and this company developed these products. So California has historically done a lot of work in the field of dynamics and overall in the field of civil engineering, because of the fact that they have to face a lot of earthquakes. So in US, this is one region which has to face a lot of earthquakes, and therefore a lot of work is done in the California state. All right. Okay. So where was I before this? Yeah, no, FEM is done. I was just mentioning California and why it has done a lot of work in this field. Okay, so I think we have understood the historical perspective. All right. So now I will just take you back to our presentation, and I was talking about the scenario of ERED for steel buildings. So as I was telling you that in USA and in countries of Europe and Oceania, Another country which actually does a lot of work in earthquake engineering is New Zealand. Okay. In New Zealand, they do a lot of work in the field of earthquake engineering. Why so? Because New Zealand faces a lot of earthquakes. It has faced a lot of earthquakes in the past, and it is in the ring of fire. Yeah, it is in the ring of fire, the Pacific Ring of Fire. There are major fault lines that run through the uh, islands of New Zealand. So New Zealand historically has done a lot of work in this field because they have to face it. One who has to face it will work on it. So Australia does not do that much work when it comes to earthquake engineering, but New Zealand does a lot of work. Given its size, I think its population is only how much? 1 CR, I think. 1 crore or 2 crores. So, in spite of having such a small population, it does a lot of good work in the field of earthquake engineering. But still, when there was an earthquake in New Zealand, I think in the year 2015, the last big earthquake in New Zealand was, I think, in 2015, the Christchurch earthquake. That caused significant damages over there. Okay. There was significant destruction because of the 2015 Christchurch earthquake. Anyway, so these countries did a lot of work, and because steel structures were adopted early in these countries, mainly in the US, because steel structures were adopted early, so they also developed the codes for earthquake resistant design and detailing. Okay, all these things we have covered. And in India, we did not have any guidelines or any code. Uh, we only had IS 800 2007, Section 12, which also was in year 2007. Before that, we didn't have any code. And until the launch of this new code, we did not have any specifications for ERDD of steel structures. So 18168 2023 is going to be the first time that in India now we have a special code for earthquake resistant design and detailing of steel structures. Okay. Interestingly, first when it was at the draft stage, it was named as IS 13920 Part 2. If you have read the draft of this, if you see the nomenclature used for the draft, it was named as IS 13920 Part 2. So it was thought that IS 13920 Part 1 will be for RCC and Part 2 will be for steel. But then when they released the code, they gave it a new name, 18168. Okay. And I have talked about the historical development of these codes. So then the books and documents that we had till now do not cover, or even if they cover, they are largely based on international standards. And uh, we don't have any proper design and detailing procedures for ERDD. See, whenever I'm going to use this word ERDD, what will it mean throughout the course? If I use the word ERDD, it will mean the earthquake resistant. Hello, what will it mean? It will mean earthquake resistant design and detailing. Okay. So for short, I will use ERDD. So the books and documents till now that we have for uh, ERDD of steel structures, either they don't cover this topic at all, or even if they cover, they are largely based on the international standards. In fact, till now we don't have a proper book, textbook at least, which covers the 13920 2016 properly. I mean, I have not seen at least. Has anyone seen any good book, textbook I'm talking about, which covers through solved examples the use of 13920 2016? Anyone who has seen any textbook on that? Hello. 2016 is 13920 is the RCC Ductile Design and Detailing Code. Anyone who has seen any good textbook on that? Okay. Yes. Rajenji is saying Shri Khandeja. Khandeja. Khandeja Agrawal. Shri Khande. Shri Khande Agrawal is a. हाँ श्रीखंडे अग्रवाल मनीष श्रीखंडे प्रोफेसर मनीष श्रीखंडे एंड प्रोफेसर पंकज अग्रवाल या both of them are professors at IIT Roorkee EQ department. So IIT Roorkee has a separate department of earthquake engineering. I think it is the only IIT in India to have a separate earthquake engineering department. And Professor Manish Srikhande is from my city, that is Indore. Professor Manish Srikhande, he is from my city, Indore. Yeah. And Professor Pankaj Agrawal was my external. Professor Pankaj Agrawal was my external during my MTech dissertation. So he had come as an external. So in IIT, they don't call professors from outside, they will call professors from the other departments. So Professor Pankaj Agrawal was my external for the MTech dissertation. So he had asked some difficult questions during my external. Anyway, so Acha, so their book covers solved examples on 13920 Does their book cover solved examples on this? Beam column capacity ratio or joint shear? Do they give solved examples for that? No. Yeah. So that's what I was asking. Is there any textbook which covers 13920 with solved examples? No. That's what. So I'm saying even after yes. Mr. Kashyap is saying yes. Okay. If there are some good books, please tell me. I would also like to read them. Rajenji is saying, but only two examples are there. Acha, they have given, but only two examples. Okay, okay, understood. So the problem is that we don't get good texts, we don't get good books, which will cover all these aspects of standards or codes. So if we don't have a good textbook for concrete structures, ERDD, we surely do not have anything on the steel ERDD, isn't it? So books and documents are either based on international standards or they don't cover this topic at all. So therefore, what we do that most of us as structural engineers, we rely either on some standard details, some practices that are adopted in the design offices, or we simply ignore this issue of ERDD of steel design for an actual project. Okay. But now what has happened, and this I had talked about in the introductory session also, what has happened now that more and more steel structures, see earlier steel structures in India largely were steel structures in India largely were your warehouse sheds, isn't it? In India, the steel structure was mostly used for this truss-like system. They call it as the kechi. So they call the truss as the kechi in colloquial usage. So the steel structure was used only for these types, or then over the recent years, you have these portal systems being used for steel sheds. So largely your steel structures meant that warehouse banana hai. So for warehouse, you will make a steel. And for these structures, I think you will appreciate that seismic is not an important criteria. Why seismic is not an important criteria for it? Because these structures are mainly uh, critical in wind because of their low weight. Seismic loads are not much, so they are more critical for wind loads. So therefore, nobody pays attention to the earthquake load calculation and design of these structures for earthquakes. But now what is happening? What is happening now? That now more and more framed buildings, even for residential and commercial, are being built in steel, isn't it? If you see now, more and more multi-storied constructions are happening for steel structures as well. So now a need is there in India, a need is there now that there has to be procedures and practices developed for ERDD of steel buildings as well. And that is where this code comes in. Okay. So that is, I think, is the need. And therefore, this course we started. This slide I had covered in the introductory session also. So through this course, we will try to provide all of the participants a platform to have an in-depth understanding of the ERDD of steel buildings, and we will have a clause by clause understanding of IS 18168. See, 18168 is a copy paste from AISC 341. Okay, it is absolutely a one-to-one copy. All right. So when we will discuss 18168 in the process, we will also understand the American codes. I think one thing that is good right now is that IS 800 2007 is largely taken from AISC 360, and this new 18168 2023 is largely taken from AISC 341. So when it comes to steel structures, the Indian codes now are at par with the international American practices. Okay. Hello. Do you understand? Because they are direct lift-offs. They directly lift the clauses from American codes and put it in the Indian code. But that has meant that now our Indian codes are at par with the American codes, and the philosophy is almost similar now. So if you are reading Indian codes properly, you will get a good sense of the American codes as well. Do you understand? Hello. So those who are practicing in countries outside India, or also those who are doing structures for other countries which use American codes, this course will help them also, because if you understand Indian codes, you will also get a sense of the American standards. All right. Yeah. So through this course, we are going to enable a clause by clause understanding of 18168. Of course, we will discuss the implementation of these clauses and provisions while using commercially available softwares like ETABS, STAAD, and Idea Statica. You must understand that the provisions and clauses of 18168 are not inbuilt right now in these softwares. Do you understand? Hello. The provisions of IS 18168 are not inbuilt in ETABS or STAAD or Idea Statica. So while implementing these clauses, we will have to do a lot of jugaad to make our way while using this software. Okay. Is it clear? Okay. So Mr. Ayal is saying, but sir, if it's a copy of AISC 341, can't we just use 341 in software? Actually, you can, but what they have done, 18168, is that while copying, they have made it more conservative. More conservative means they have put some additional safeties. So what the Indian Codal Committee typically does is that it picks up a clause from the international standard and then it tries to make it more safe when it puts in the Indian code. So it makes it 1 degree or 2 degree harsher for the Indian engineers. All right. So therefore, we may not be able to directly use 341 because our codes have been made more conservative. And I'll tell you along the discussion which clause has been made more conservative or which provision has been made giving higher safety factors. Uh, I'll tell you when we go through the clauses. Okay. Yeah. So through this course also, we will enable the participant to understand this whole issue of ERDD in a better light. I think I had discussed this slide in the introductory session as well. And what is the approach that we are going to follow? So we will be moving from part to whole. That means, and this is how the code is also, this is how the AIC 341 as well as the IS 18168 have been formulated, that they first talk about the elements. First, they talk about the basic elements, which are the basic elements in any lateral load resisting system, which are the basic elements. So your basic elements will be the beams, the columns, the beam column joint, the column bases, the braces, structural braces, the structural links. So all these are the elements. So first we will discuss the requirements, the ERDD requirements for all these elements. We will discuss that first. That is how the code is also presented, that it first talks about the elements. After this, we will talk about the lateral load resisting systems. So once you integrate these elements together, so that means, for example, I integrate my beam. I hope you can see this image. So I integrate my beam, I integrate the column, and I put the joint, BC joint. So when I integrate this system together, what do I get? Sorry, when I integrate these elements together, what do I get? These are column bases. Yes, what will I get? On integrating these elements together, I will get my lateral load resisting system, isn't it? Which will be a moment resisting frame. Are you able to get it? Hello? Yes, no? So first, we need to understand the basic elements, or what you can call it as the basic building blocks. Once you understand the provisions for these basic elements, then we can integrate them and understand about the system as a whole. I hope this is making sense. Yes, no, quickly. No or yes? Or we integrate all these elements together, let's say. So this is my beam, this is my column, this is my column, this is my column base, this is my BC joint. These are what? These are my structural braces, and this is my link. So when I integrate or put these elements together, then I get my lateral load resisting system. Okay. This type of a system will be called as a eccentric braced frame. So in the code, three lateral load resisting systems have been detailed, and they are the special moment resisting frame, the special concentrically braced frame, and the eccentrically braced frame. So once we discuss these basic elements, then we will discuss uh, these three lateral load resisting systems. We will I think this is done. Clause by clause reading. This is the approach. Of course, it will be part of the approach. So uh, we will be having a clause by clause understanding of 18168, and also time to time we will refer to the other codes like IS 800 2007, the AISC 360 2022, and the AISC 341 2022. And wherever required, we will take up analytical models, small models in this software to understand the ERDD principles in a better way. This is the, I'm talking about the approach that we are going to follow in this course. And then we will also take up a sample building in the end, which will be designed as per the principles of 18168. So this is the approach. So we will be moving from part to whole, uh, from understanding the basic elements to the LLRS, or the lateral load resisting system. And the course contents, we have talked about this in the session 1 also, but just going through it very quickly. So as I was telling you, all these are the basic elements of ERDD steel structures. So you have got the beam column joint, the column base, the structural braces. Then you have got the links. And once you understand the elements, then we will go to the structural steel systems. So three structural steel systems we will discuss: SMRF, SCBF, and EBF. And then, as I told you just now, we'll take up an actual project to understand these things. So this was the approach, and this was the these are the course contents. And of course, I have talked about the codes. Here 16 is written. You can make it 22 as well, because the 2022 revision was launched last year for AISC 360 and AISC 341. So today what we have discussed, today we have discussed the historical development of these various standards, and what is the scenario when it comes to American standards, and what is the scenario when it comes to the Indian standards. So all these things we have discussed today. Tomorrow we will start with understanding what is the basic underlying philosophy of earthquake resistant design and detailing. Okay, it is very important that you understand what is the thought behind the ERDD, behind the ERDD. Okay, once you understand the philosophy, then the codal provisions will start making sense to you. I think this we will start tomorrow. I wanted to do it today, but it will be better if we can do it tomorrow. All right. Is it clear? Hello. Yes, no. Yes. So all of you have been added to this. All of your email IDs have been added to our portal, where you can watch the sessions. Each session will be uploaded after about 2-3 hours of conducting, and it will be put on our portal. So anyone who is facing difficulty in accessing the portal, hello, anyone who is facing difficulty in accessing the portal, so this is the portal address, oxen.spei.com. You need to go to this, and then you will go to these courses. Okay, so I don't have any course right now. So you will go to the courses, and then in the courses, you will get to see the course. The detailed procedure has been shared with all of you. Is it clear? Hello. Okay. So tomorrow when we meet, we will start with the the underlying philosophy behind the earthquake resistant design and detailing. Yes, Rajanji is asking, truss bottom chord and truss column connection is always pinned. No, you can give it a rigid connection also, but one thing is it is difficult to develop a rigid connection over there. And when you give a rigid connection over there, the problem is that the truss does not behave in the way you want it to behave. So generally we avoid giving a rigid connection at the bottom chord of truss. Usually it will be a pin roller or a pin kind of connection. Okay. Yeah. So I hope today's session was understood by everyone. We will meet you tomorrow. And until then, that's all we have. Thank you. Rajanji is asking, so the column is always a vertical cantilever. Yeah, sometimes for connections that are pinned and roller, it will be a vertical cantilever. For connections which are pinned, it will be a propped cantilever. Yeah, or propped cantilever. Yes, correct. Okay. All right, then. We'll see you tomorrow. Thank you. Bye bye.